Let's start with Terafab, a company vision for 100 million square feet of chip and compute manufacturing. Now zoom out. It's only one piece of a much larger production system taking shape across Texas. Texas isn't one giant factory, not yet, but the pieces of a technology megaregion are taking shape. Chip fabs, AI campuses, battery plants, ports, and launch sites. Power, water, fuel, and freight connect these pieces. But any weak link within a facility or between facilities can constrain the entire network. To see what Texas's technological future could look like, we'll assemble this megaregion piece by piece. Chips, compute, batteries, logistics, and launch. Then we'll trace how those pieces could work together and identify the weak links that could slow down the entire system. A technology megaregion doesn't have an official boundary. It is a web of distant places that function as one production system because parts, power, people, data, and finished products move between them. Silicon Valley and China's Pearl River Delta show how this can work. Many cities forming one compounding industrial ecosystem. Texas is different, but the test is similar. The research calls it delivered industrial throughput per constrained input. In plain English, how many chips, vehicles, batteries, shipments, compute workloads, or launches can the system produce when its most constrained requirement sets the limit? Call it the weakest link test. Announced investment and square footage measure ambition. The weakest link determines how much of that ambition becomes real output. Before we search for the weak links, let's assemble the best case scenario. In Central Texas, several of the key pieces are already taking shape. Samsung's Austin fab provides an operating semiconductor anchor, while Taylor is the advanced expansion intended for high-volume production. Nearby, Bastrop manufactures Starlink hardware, while Giga Texas brings together vehicles, batteries, robotics, and AI compute. Follow the map south, and Corpus Christi extends the battery chain with lithium refining. To the west, Abilene hosts OpenAI's flagship Stargate compute site. Near Fort Worth, Northlake's announced magnet campus adds another critical piece, domestically produced rare earth magnets. Then the map reaches South Texas. The Port of Brownsville provides maritime access and heavy industrial logistics. Nearby, Starbase brings rocket manufacturing, testing, and launch together in one enormous space flight complex. Terafab could add something unique to the chip network. Mask production, logic and memory fabrication, advanced packaging, and testing in one facility. Engineers could make a chip, test it, revise the mask, and begin the next version without moving each stage between separate sites. If the link matures, Texas does not have to become one continuous city. It becomes a true technology megaregion when what one place produces becomes what another place needs. When that exchange repeats across the map, the benefits begin to compound. A stronger chip base supports more compute and autonomy. Growing compute demand can attract investment in power, cooling, construction, and networking. Repeated production attracts specialized suppliers, equipment technicians, and training programs. Each successful node creates more demand that makes the next one easier to build. Which Texas node matters most? Tell us in the comments, like the video, and subscribe to Galaxial Frontiers for more technology explorations. But lines are easy to draw on a map. Making them work is harder. Each connection needs a real agreement, a working route, enough capacity, and every piece ready on time. So now let's see what happens when one link falls behind. Start with power, the requirement every major node shares. As more fabs, AI campuses, battery plants, and launch sites come online, they place more pressure on the grid. Texas may generate enormous amounts of electricity, but a project cannot run on a statewide total. It needs reliable power delivered to its specific site through the right transmission lines and substations when it is ready to operate. ERCOT's Large Load Review asks whether projects of this size can connect without threatening grid reliability. Transmission lines, substation upgrades, interconnection approvals, and costs determine when that power actually arrives. But securing power creates the next constraint: heat. Dense compute creates enormous heat. Closed-loop systems recirculate coolant, but they still have to release that heat. Facilities can use water for evaporative cooling, or consume even more electricity to cool the system with fans and chillers. At Starbase, the pressure shifts to fuel. A higher launch cadence could outgrow tanker truck deliveries. SpaceX has proposed Starpipe, an 8-mile natural gas pipeline connecting the Port of Brownsville area to its launch complex. It shows what frequent launches require, not just more rockets, but also an industrial-scale fuel supply. Every node has a different weak link. Whichever one falls behind can slow down the rest of the network. Now put that rule to the test. Switch off every proposed project and unproven connection. What remains is impressive: operating factories, compute campuses, materials production, logistics hubs, and launch activity. But instead of one statewide system, the map breaks down into separate clusters. Terafab still has to be built, Taylor still has to reach full volume production, Northlake still needs customers for its magnets, Starbase still depends on licensing, fuel, workers, and supporting infrastructure to expand. Across such long distances, different owners, utilities, schedules, and incentives make coordination harder. Texas could build an extraordinary collection of projects without forming one connected production system. That is the counter case. Not failure, but a slower future where major projects grow without forming one connected production system. That slower future is not inevitable. So what would turn these separate clusters into one connected megaregion? Not another billion-dollar announcement. The real evidence will be less dramatic. Substations energized, transmission built, water secured, chip-making tools installed, production lines qualified, freight and fuel capacity expanded, and workers trained and housed. Each milestone turns a planned project into a working part of the network. So is Texas becoming one giant tech factory? Not literally, but it could function like one. A technology megaregion where chips, compute, batteries, manufacturing, logistics, and launch reinforce one another across the state. Power may constrain one node, water, manufacturing yield, fuel, freight, workers, or permits may constrain another. In every case, the hardest requirement to secure determines how quickly that node can join the network. Now return to Terafab. It may become one of the largest factories ever built, but it would still be only one piece. If the network around it comes together, Texas could turn a collection of giant projects into something even larger. A state-spanning technology megaregion unlike any built before. Thanks for joining us on this Galaxial Frontiers exploration. I'll see you in the next video.